Hi everyone, this is Dr. Mohana Roopa, working as a professor in the Department of Computer Science and Engineering at Institute of Aeronautical Engineering, Hyderabad. Welcome to all for the lecture series of Software Engineering course. Today topic, Software Process, Perspective and Specialized Process Models. The contents in that topic, those are software process models, under that prospective process models and specialized process models. First of all, what are the outcomes of this topic? The outcome of this topic is illustrate process models, approaches, techniques for managing a software development process. This is the major outcome of this topic. So first go for what is process. Process is a collection of activities, actions and tasks that are performed when some work product is to be created. So generally a structured set of activities are required to develop the software system. So a structured set of activities required to develop a software system. So majorly many number of activities are there under that. The software process, major activities under that software process consists of specifications, design and implementation, validation and evaluation. These are the steps or common steps in our software development process. So specification means defining what system should do. Defining what system should do is called specification. Under the specification, the software process consists of defining what system should do. Those are the information are there in the specification activity. So next one is design and implementation. Once the specifications are over, then defining organization of the system, how one system is connected to other systems, as well as what are the subsystems are need to put in the complete system. So like that things, as well as implementation, how we can implement the system, what are the programming languages that need to implement that system. Those are there in our design and implementation process activity. So next, validation. After completion of the program generation, next activity generally it is validation. Validation means checking that it does what customer wants. What customer wants, that is satisfied through these implementation or not. That is there in the validation process. Once the validation process is over, then go for evolution. Almost all cases, what any system changing the system in responses to changing customer needs, that is evaluated by the evaluations, right? So these are the major different activities the software process consists. So the software process framework is also important. A generic software process framework for the software engineering encompasses 5 activities. What are the 5 activities? That is, first one is communication. Almost all cases it is in the generic software process framework, which can consist, first phase of activity is communication. First communicate with the customers or the clients based on their requirements. Next phase starts. So next phase is planning. So how we can do the project? What are the planning activities are made, like project scheduling and cost estimation, budget estimation. All those things are also covered in the planning. So next, what are that framework activity is modeling. Once planning is over, based on the planning, designing or models are created. So once the models are created, then they go for construction phase. So by seeing the models, the construction is very easy in normal generic software process or generic software engineering or normal engineering. Once the models are over, by seeing the models, the construction is how it is easy. Similar way here, software models are created. Once the models are created, then by seeing the model, the construction nothing but implementation here in the software engineering. So that's why the writing the program is also very easy. So that is there in the construction. Next to go for deployment. So construction is over, the product implementation is over, then go for verification validation process is over. Then next generic activity of the framework is deployment. Deployment means delivery the product to customers in a correct manner. So that those are the activities are there in the software generic software framework. Here we discuss about that the process flow activities are generic activities are defined. So then the based on that activities are used in our development process. So the process based on the process flow, we can go for the development. So the process flows are, so first one is linear process flow. So one is linear process flow, which can contains that the activities are in a systematic manner. So one by one. So sequential manner. First one activity is over. Suppose communication. The first activity is communication. The communication is over. Then go for planning. So then go for modeling. Then go for construction. Then go for deployment. So first one by one. For the entire project, so communication is over. That means requirements gathering is over. Analysis also over. Based on that analysis, next to go for planning phase. Once the planning phase, how much estimation of the budget as well as the planning number of resources requirements, everything is also covered in our planning phase. Once that planning is over, then go for modeling. Based on the planning, so the models are developed. So once the models are developed, models in the sense what are they? They depend simplification of reality. That means complete project is shown in terms of the pictures. So different angles, different views like structural view, like behavioral view. So all those views can model. So once the modeling is over, then go for construction, means implementation. Once this one is over, then go for deployment. Like that way, complete what are that? Complete activities, communication completed, then go for planning, then go for modeling, then go for construction, then go for deployment. So these are the activities are there in the linear sequential manner or linear process or linear sequential process, whatever that. Next to go for one more process method, that is iterative process flow. So in this iterative process flow, which can contains the same activities, but the activities linking is different. So the way of completeness of this process activity is different. Suppose first phase, what is that? Communication is completed, then go for planning. After planning, suppose some other modules or some other things are we can again planned, then go for collect that communication, the requirements collected from the communication phase. So that's why iteratively the planning is over, then go to back phase, that is communication. Again communication, from the communication phase collect that information, again do for planning. So this in this way also the communication, planning as well as modeling. So in the modeling, again the once completement of the modeling, again do for the models for another kind of subsystems or other modules, then again do that model. So that is modeling. So once the modeling is over, then go for construction. So in that construction, again need what are that? Some other information from the communication, again go for the communication, there also develop that requirements, again go for planning, such type of requirements include in the planning, include in again modeling, then go for construction. Like that iteratively for subsystems and other subsystem we want to do that the models or the construction or implementation or what else. So again go for the communication, then planning, then modeling, then construction. That means whenever or whichever phase required the previous phase, again go back. So this facility is there in the iterative process model. Once completement of all these phases, finally go for deployment. Finally go for deployment. So this is there in the iterative process. Iterative process. So then next kind of process flow, the next kind of process flow is evolutionary process flow. Evolutionary process flow. That means suppose some different kinds of projects have different modules. First different modules and different whatever that incrementally we have to do. So then first phase or first module contains all phases like communication. Next one is planning. Next to go for modeling. Next to go for construction. Finally deployment. First phase of activities is over for one module. Then go for next module. So that's why. So what is that? Communication. Then planning. Then modeling. Then what is that? Construction. Deployment. Finally one increment is over. One module is over. Then go for what are that? Then go for another module for the same process going on. So that's why it is called evolutionary process model. Evolutionary process model. I mean evolutionary process flow. So these are the different kinds of flows which are used in our process models. So next kind of process flow is parallel process flow. Parallel process flow, first of all communication, planning is over. Then whatever that modeling for some subsystems. So for again go for some part of the system, communication parallel, planning, then go for modeling. So like that for complete total number of system can be divided into some subsystems. Then one subsystem contains suppose communication planning and second whatever that second subsystem goes for communication. So suppose first subsystem in the first subsystem or the module goes in in subsystem in the construction phase. Suppose it is in the construction phase, module number 1 in the construction phase, then module number 2 it may be in the modeling phase. Like that parallelly all the works, all the modules are completed, final document is deployed to the customers. So these are the different what are the process flows are available in our software process development. So software process contains the framework activities. This is also the important aspects of the software engineering, that is software process framework. Software process framework. So software process contains software process framework. So the framework contains that umbrella activities. These umbrella activities again the inner layer of that umbrella activities are framework activities. So what are the framework activities are appropriate actions. What are the actions are appropriate for the framework activities given the nature of the problem to be solved. The characteristics of the people doing the work and stakeholders who sponsoring the project, all those things are covered in the framework activities. All see here. So what are the software engineering actions? Action 1.1, suppose action 1.2 and so on 1.k. Like that, what are that one software engineering actions contains what are that software tasks. So tasks also contains work tasks and work products, and what are the quality assurance patterns as well as the project maintenance. All those things are there in the software engineering actions. Now one by one, what are the umbrella activities, what are the framework activities? Generally the framework activities already defined. So the framework activities are communication, planning, next one is modeling, next one is construction. So next last one is deployment. So now go for the umbrella activities. What are the umbrella activities inside that? The software process. So those are software project, almost all what are the umbrella activities are software project management activities. So those are software project tracking and control. So that is also an activity. So allows the software team to assess the progress against the project plan and take any necessary actions to maintain the schedule. As per the schedule that is going on, the product development is a product working development is going or not, like the things are there in the project tracking and control. So risk management, so whenever the risks are occur at the time, though what are the how the project affected by that risk, so how much damage will get, like that things are also analyzed in the risk management, as well as how to control that type of risks. Those are there in the risk management activities. These are under umbrella activities. So next, technical reviews. That is, assess the software engineering work product uh, in an effort to uncover removable errors before they are propagate to the next activity. That means whenever go for the next activity, so many activities are involved in the software development process. When activity is over, so that particular activity is assessed by the technical reviews. Okay, any errors come, how we can overcome that, or how we can remove that type of errors, such type of things are there in the technical reviews. Next kind of what are that activities under that umbrella activities in the software framework. So those are software quality assurance, check the quality of the product. So how we can assure the quality for the product. So like that things are there in the software quality assurance. Next one is measurement. Measurement defines the collects the process project and product measures that assist the team in delivery of the software meets stakeholders needs. That is based on the stakeholders requirement, the product is satisfied or not. Such type of measuring techniques are also used in the software processor, in the software processor. So that means next to go for software configuration management. Manages that affect the change, what are the change throughout the software process. Through the software phases, any changes are there, those are how those changes are affect the product, like the things are discussed in our software configuration management. Some other what are the umbrella activities like reusability management, as well as work product preparation and production. So these are the umbrella activities are there. So next to go for what are the software development process model. So software development process model is an abstract representation of process. Software development process model is an abstract representation of a process. It is software process model. It presents description of a process from some particular perspectives and a particular perspective point of view. What are that the description is there in the software development process. Whatever that actually the software process model is an abstract representation of a process. That means every process contains the generic activities, those are there, and some specific activities are also involved in the different process models. Here the process models are two kinds. What are that? Prospective process models. Second one is evolutionary process models. Two kinds of process models are there. Prospective process models. Second one is evolutionary process models. Prospective process model contains again what are that? Waterfall model, V model, incremental model, Rad model. Rad means rapid application development model. So next, the evolutionary process model contains prototyping model, spiral model, concurrent development model. These are the different process models. Always the process models gives us the abstract representation of a process. abstract representation of process. First, prospective process model is waterfall model. Waterfall model, called other name for the waterfall model, it is classic life cycle model or linear sequential model. So this is a very oldest process model. This is a very traditional model, software development process model. So the activities are arranged as per the linear process flow. So that means, first of all, the complete product starts with the communication. Always communication gives us requirements gathered from the clients or the customers. So discuss with the customers and collect that requirements, and those are put in the form of a specification. SRS document, a requirement specification document, is also prepared in the communication phase, right? Project initiation, requirement gathering is there in the communication. So for entire project in the waterfall model, for entire project, first of all, whatever that requirements are gathered. So it is not divided into some subsystems. Complete product, it may be a long project or it may be a short project, whatever that. So complete first phase is over, then only go for next phase. Once complete requirements are gathering, that process is over, then go for planning, right? Then go for planning. What are that planning? So planning is estimation of scheduling. So cost estimation of the scheduling, in the sense it may be time, development time estimation or cost estimation or resources estimation or whatever. So all those things are there in the project planning. So for entire project, the planning is over, then only go for what are the next phase, that is modeling. So the modeling is, in that modeling particularly analysis and design is going. So once the requirements are gathered, collected, that requirements are analyzed, and based on the analysis do the design, software designs developed. So okay, so that is there in the modeling, or software models are prepared in the modeling. So analysis and design part is there in the software modeling. Next, what are that? Next one is construction. So that is code generation. Once the models are over, then only start that complete construction. That means implementation, or what are that? Development is going in the construction phase. So once complete the construction, implementation or write up of the program is over, then only go for deployment. That means deployment is delivery support, as well as whatever that the feedback, maintenance, annual maintenances, as well as whatever that any feedback collected from the customer, again whatever that. So based on the feedbacks, again go for the any things are needed to improve, again go for the development phase, take that improvement and do that construction. Again construction. These are the things are there in the waterfall model. So the communication, next planning, modeling, next what are that construction, next deployment, all phases, all framework activities or process framework activities are going sequentially. This is called linear sequential model or waterfall model or classic life cycle model. So every life cycle models, software development lifecycle models contain some metrics and D-metrics. So every process model contains metrics and D-metrics. Based on this one, so which software development process model is suitable to our product generation, those only considered and follow that as per that steps, as per the development cycle, we can go for software development process, right? So waterfall model metrics are, it is a systematic sequential approach for software development. There is no deviations. First phase to last phase, one by one, that is going. Systematically, it is going all phases to develop the software. So D metrics, what are the D metrics of the software waterfall model, which can contains all customer requirements that at the start of the project may be difficult. Always it is so much very big projects you may take, at the time, at the beginning only, all the requirements gathering is somewhat difficult. For a very small projects, it is okay. So whatever that, first of all, gather the requirement, then go for planning, then go for modeling. So but for large projects at a time, completement of requirements gathering is somewhat difficult. That is the one of the D metric of waterfall model. So one more D metric is problems maintained uncovered until testing phase. So we can't whatever that find out that problems until the testing phase. Whenever first requirements, then go for planning, then go for modeling, then go for construction, next go for testing. So okay, testing up to testing, in any phases we can't identify any kind of errors and all. So once completement of all phases, then the before the deployment, the testing, when the testing task only we have to identify the errors. If errors are come, again go for planning, again go for design, again go for implementation. Like that way it can take some lot of time. Okay, so that's why it is also one of the D metric of waterfall model. So then one more D metric, that is customer patience is needed. Working versions of the software is delivered to too late, because it is too late. Delivery is too late because one by one complete all the phases of for the entire project. Then only we have to deliver to the customers. Otherwise, it is too difficult. That's why these are the major D metrics are there in the waterfall model. Right. Next, go for one more model, that is perspective process model. So that is V model. V means verification and validation model. So it is actually representation. It's a variation of waterfall model is called V model. In the V model, left side of the V, which can contains as usual process framework activities. So each and every framework activities is at the time of the completement of that one type of testing is completed. So that's why in any phase at a time we have to identify any errors. Those errors are rectify in this particular phases. That is the advantage of V model, verification and validation. So first is requirements modeling. As per our communication, the communication point of view, whatever that requirement gathering. Once the requirements gathering is over, the system testing approach as well as acceptance testing approach apply on the requirement gathering. Then any type of validate, whatever that errors or the or other things are need occur at the time, overcome those errors and all, and recollect the requirement gathering sufficient or efficient requirements for the particular product development. Then go for architectural design. So design the product. So once the design phase is over, based on the requirement gathering, the architectural design is over. So once the architectural design is over, then apply the system testing as well as integration testing. Both testings are applied on the architectural design. If they have some gaps or any errors occur, again in that particular phase only those are rectified. So that is the advantage of this any phases, any framework activities testing required. Validation required. So then what is that component design? Once the architectural design is over, different kinds of components are also designed. Those are fit into the architecture. As per the architectural design, then the components are designed. Right, the components design, that phase is also required the unit testing as well as integration testing. So those things are completed. If any errors are come, again rectify in the component design only. So once the component design part is over, next to go for code generation. So up to now, more number of what are that testings or validation process is over here, each and every phase. Then finally, this design is accurate design will come. So based on this design, next to code generation is completed. So the code generation part is over. As usual for testing, that is called unit testing. Apply the unit testing and what are that here, complete that testing process of code generation. Once the code generation is over, then go for as usual what is that deployment. So that's why here each and every phase validation process is completed. Then go for next phase. Then go for next phase, like that. So here, as earlier said, what are that? Any software process model contains metrics as well as the D metrics. So that's why, so V model, the metrics are easy to understand. It is very easy to understand. Testing methods like what are that? Planning, test designing happens well before the coding. Well before the coding, whatever that once the testing method, apply the testing methods and the process, that phase is completely correct, then go for the next phase. So this saves, that's why so many validation processes are going. That's why lot of time, saves the lot of time. So one like what are that? Waterfall model, all phases are complete, then go for the testing, in the sense there the errors are come, again go for the first phase to last phase. So it can have some much of time, but here each and every phases are verified before going to the next phase. That's why any errors are there only, that those are rectified. That's why the saved a lot of time, hence a higher chance of success over the waterfall model. So what are the D metrics? D metrics of V model is not a good for complex projects. It is not a very good for complex problems. So software is developed during the implementation stage. No early prototypes of the software are produced. So that is also one of the biggest D metric. So next one is any changes of happen in the midway, then test documents along with the required document has to be uploaded. So again go for the first phase, again test, again next to go for the next phase. Suppose we have to add some changes in the middle of the development, in the product development, then again those requirements are added in the first phase, again test, again go for architectural modeling, again go for design, again go for generation. That's why each and every time we have to add the requirements or changes. Every time those changes are also what is that? Verified or validate. That is also one of the D metric of V model. Next kind of model is incremental model. It is also one of the model, that is incremental model. So what is that incremental model? In the sense, the linear process flow is also there, as well as parallel process flow is also there in the linear incremental models. Incremental models follows that linear sequential model, linear flow, as well as what are that? As well as parallel flow. So here total product development can be divided into some sub modules. So total system can be divided into some sub modules. Then whatever that, it is very suitable for incremental model application. So that means first incrementally. So one part of the that means total product can be modules are the task. So a task first completed, then go for second task, then go for third task in the actual linear models. But here what happened? The first task contains the same flow, that is sequential flow, that is linear flow. So what is that? Communication, planning, modeling, construction, deployment. So the task one contains what is that? 5 phases. So these 5 phases are also there for the second task. Next go for third task, but those are also parallelly going. So here suppose task 1 contains going the communication, what is that here? Process, planning, then go for modeling. So while modeling the task 1, second what are that? Task start the communication as well as planning, modeling. So next what are that? The third what is the task? Start that communication, like that. Parallelly the total product development is going. So that is there in the incremental process model. So one first delivery of the first increment. So like this. Okay. So next it is not completed for the second increment in parallel. So the first task in the modeling phase, second task start with communication. third delivery of the product, third part of the product start with communication while it is in construction. So like that way, parallelly, the activities are going in the incremental process model. So incremental process model has also metrics as well as D metrics. So here the less metrics or less number of the developers are required. So next one is all the requirements need to be known at the beginning of the project, as well as the technical risk can be managed. So these are the metrics of a incremental model, as well as the D metrics of incremental model, or the problems remain uncovered until testing phase. This is as usual like what are that V model here. Here also the problems remain until the testing phases. The customer patience is also need working versions of the software is delivered too late. So that is also one of the D metric of incremental model. Next model is what are that incremental rad model. That is rapid application. Rad in the sense rapid application model. Rapid rad model means rapid application development model. Rapid application development model. So here, what is there? Communication as well as planning is over, depends on the schedule of the time. Some of the team work it, so many teams are there in the project development. So one team is going on what is that modeling and construction of one module. For the second team of the people can do the modeling and construction for the second task or second module. Some other people working on modeling and construction for another module. So once the communication and planning is over, then the modeling and construction is going for different modules. Once complete all the tasks, then only the deployment process is going. That is integration, delivery and feedback is there in the deployment. So that is there in the rapid application development. So what are the major metrics are there in the process? This rapid model in the sense project cycle time is reduced. So because parallelly some of the activities are going, so once completement of all the tasks and gathered all the things and then apply the deliver to the products. So what are the D metrics of RAD application model, application development model in the sense all customer requirements at the start of the project may be difficult. It is difficult. Customer requirements at the starting is also very difficult. For a large projects, high human resources are required because so many human resources are required because so many teams are working parallel. So that's why number of people are also required. So next, that is also one of the D metric. Next one is risk of project failure if team is not communicate to rapid fire action. That means immediately any action is not taken whenever the failures are occur at the time, whatever that here the risks are also occur in the project development. These are the prospective process models. What are the prospective process models? Waterfall model. One is waterfall model. Second one is incremental model. Third one is iterative models or V models. Then incremental rapid application model. These are the prospective process models. Next to go for evolutionary process models. Next kind of process models are evolutionary process models. What are that evolutionary process models? Evolutionary process model is combination of iterative and incremental models of software development life cycle. So evolutionary process models contains a combination of iterative and incremental development life cycle. So under that some more process models are there. That is one is prototyping model. What that prototyping model tells us, what that is a quick very quick design leads to the construction of prototype. prototype. First, prototype model always gives us what is that prototypes design. So by seeing that prototypes, then go for the other type of phases. Other phases are going in the prototype models. Prototype model is also starts with the communication. Every process model is also start with the communication. That means stakeholders, meet the stakeholders, not only the clients, the end users. Point of view is also collect that information. That means gather the information and define the overall objectives. Define the overall objective. This is the major point of prototyping model. Communication, communicate with the stakeholders, all stakeholders, and define all overall objectives of software. Overall objective of the software. It is identify whether the requirements are known or outline areas where the further definitions are mandatory or what else. All the things are considered and maintained. So here prototype iteration is planned quickly and modeling is also quick. It is very quick process model. So prototyping model contains the what are the phases or communication, as usual communication. So then here generally planning. That plan is also very quick plan. So then quick design, that is communication, then plan, then modeling is nothing but analysis and design. That's why quick design. Then go for prototype construction. So construct a prototype, construct a model, construct the models and the prototypes. Then go for delivery. While delivery, again consider that feedback. So based on the feedback, go for the communication and quick plan and quick design. Then go for plan, prototype construction, delivery. All are in a cyclic manner. Or prototype model contains all these phases of the activities are in a cyclic manner. So here the prototype model has also the metrics as well as the metrics. So prototype helps the requirement gathering can be applied at any stage of the project. So because every phase of the project are also required requirements. That's why whatever that prototype helps in the requirement gathering and can be applied at any stage of the project. That is one of the biggest metric of prototyping model. Next, what are the D metrics of this prototype model? It is customer insists to cover the prototype in working versions by applying few fixes. So as well as the less than ideal choice is there in the prototyping model, because once the prototypes are defined based on the prototypes, then go for the constructions. So that's why those are the D metrics. So next model is spiral model. Next evolutionary model, which can contains incremental as well as iterative. Both process flows are there in these models. Spiral model. What the spiral model? It is also the evolutionary software process model. It couples the iterative nature of the prototyping and controlled the systematic aspects of the waterfall model. So these two things are there in the spiral model. Iterative prototyping as well as controlled systematic aspects of waterfall model is there in the spiral model. It provides potential for rapid development of increasingly more complete versions of the software. The main it has main distinguished features. That is, one is cyclic approach for the incrementally growing a system degree of definition and implementation while decreasing its degree risk. These are the two distinguishes. One is cyclic approach. Another one is implementation with the decreasing of its degree of the risk. That is there in the second spiral model. Software development in series of evolutionary releases. During early iterations, the release might be model or prototype. So the prototype model as shown like this. The planning. Here the planning contains planning First start with the communication. Communication later go for planning, later go for modeling, later go for construction, next deployment. Communication, first two iteration, it is also the cyclic, it is also like a prototype. One communication, one path is over, then the planning, then whatever that here, modeling. First iteration starts with this first part of the project. So that is start. So communication for this one. Once for this part of the project, communication is over, that means requirement gathering is over, then go for planning, then go for modeling, so then go for construction, code generation, then go for deployment. Up to this, the first part of the project is over. Then again, whatever that next part may take, so then communication, again sequentially, communication, planning, modeling, then what are that construction, then go for communication. Like that, complete part wise the product development is going iteratively and incrementally. That is there in the spiral model. The planning contains what is that estimations, risk analysis, scheduling, all those things are there. Modeling contains as usual like analysis, design. Construction contains what is that code, testing. Finally, deployment contains delivery and feedback. These are the things are there in the evolutionary process model as spiral model, right? So here spiral model has also the metrics and D metrics. Metrics are risk is considered as each iteration is made. As each iteration, risks are there. So that is there in the spiral model. As well as spiral model can be applied throughout the life of the computer software. Those are the metrics of spiral model. As well as the D metrics are, it is difficult to convenience the customers, that is evolutionary approach is controllable. Evolutionary approach is controllable. So considerable risk assessment expertise required. If major risk is uncovered, problems will occur. So these are the major D metrics of what is the spiral model, which is under that evolutionary process model. Next process model is concurrent development model. The concurrent development model, sometimes called concurrent engineering model, sometimes concurrent engineering model, which can contains the series of framework activities, software engineering actions and tasks and their associated tests, all activity exists concurrently. Concurrently here, see that in active state, suppose it may be enter into the active state under the development. So what is that? Awaiting the changes, then go for under revisions. So then under revisions, then under review, then baselines and done is over. Then go for again what are that? Awaiting changes. Any go for awaiting changes. So awaiting changes are occur, any changes are occur, then under revision. So under revision, the revision is over, then go for under review. So that review is also over, go for baseline. So after this one only the done process is over. Once the process is over, then go for awaiting changes. That is modeling activity. All concurrent activities are going in a concurrent fashion in the concurrent development model. So this has also metrics and D metrics. So what are the metrics are there in the sense applicable? All types of software development product accurate picture of the concurrent state of the project. That means any type of projects is also so apply these concurrent development process model for any kind of software projects. So D metrics are problem to project planning, how many number of iterations are to be planned, uncertainty, and process may fall into what are that evolutions or too many things are also affected. That is there in the concurrent software development process model. So these are the different kinds of process models are discussed in our things. Some more specialized process models. What are the specialized process models? Are component based software development model. So the product is developed in terms of components. We have to go for component based software development model. That is commercial off the shelf components, software components developed by the vendors who what are that offers themselves are the products like that. Commercial components are collect and those are put into the architecture, and what is that generate that complete product and develop the complete product that is there in the what is that component based software development model. So which type of software development is also follows that spiral model as well as iterative nature, like iterative as well as the incremental models are also following the component based software development, right? So formal method models, this is also one of the specialized process models. So that is formal methods models encompasses a set of activities that leads to formal mathematical specifications of computer software. So apply the formal methods and develop the product models, product development, that is called formal method models. Formal method models. So next aspect oriented software development. So next specialized model is aspect oriented software development. So in this, so the methodological methodologies as well when defining the approaches, methodological approach for defining, specifying, and designing and constructing the aspects are in terms of aspects only. So aspects are mechanisms beyond subroutines and inheritance of localizing the expressions of the cross-cutting concerns. So the applying the aspects, in terms of the aspects we have to develop that software product, that is called aspect oriented software development. So these are the specialized methods are discussed. These are the what are the common references, textbooks and the web references are followed and discussed this topic as a software process models, perspective and specialized process models. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.